Okay, now before we talk about this question, I just want to talk about little more background, little more conceptual knowledge to discuss another interesting question that would make this question a lot easier for us. So let's say the question that I'm talking about is, it is range update queries I'm going to give you, and I want to know the array after range update queries. So what do I mean by that? Let's say you have an array having all zeros. I'm putting few zeros here, and I will put indices also below it. It's index 0, 1, 2, 3, 4, 5, 6, 7. Okay, I'm giving you certain queries, and those queries are, I'm going to give you a query of L, R, and update. So what this query would do, add UPD value to all indices of array from L to R, both inclusive. Okay, this is the update query that I'm giving you. So I give you a query, let's say 1 to 3 add 1. Then I say 2 to 5 add 3. Then I say, let's say 5 to 6 add 2. These are the three queries. I want you to tell me the array values after it. So if I do 1, 3, 1, which indices in this array it will modify? It will modify index 1 to 3 in this array and add value 1 to it. So can I say 1, 1, and 1? That's the change that is going to be. Okay, second query, help me process this query. We have to go to index 2 to 5 and add 3. Index 2 to 5, if I go and add 3, what will be the changes done? At index 2, the value should become now. What should be the new value at index 2? If I'm going to add 3 to every element, yeah, it is going to be 4. 4, 4, sorry, 4, 4. At index 4, if I add 3, it will become 3, it will become 3. So now our array is updated to this value. This is second update. Help me do the third update. Third update says go to index 3 to 6 and add 2. So 3 to 6 index, every index, whatever is the old value, I have to add 2. So it will become 4 plus 2, 6, 3 plus 2, 5, 3 plus 2, 5, and this plus 2. So this is the array. Let me add one last query. Let's say I tell you to add index from index 5 to 6, 7, add 1. Now what will be the change? In 5, I'm adding 1, so it becomes 6. Index 6 becomes 3, index 7 becomes 1. So I want to know the array after doing all these queries. So now the array gets modified 0, 1, 4, 6, 5, 6, 3, 1. Okay. But here, if you look at what I did, literally, I read every query and I went and updated every index in the array. For one query, what is the maximum time that it is going to take? For one query, we need a loop, right? For one query, what is the max number of iterations? You know the queries of the form L, R, and update value. So what is the time complexity worst case for one query? Ideally, we know it is going to be R minus L plus 1, because whatever is the range we are updating. And in worst case, we know that can be N. Is that absolutely correct? I can give you every query from index 0 to index N minus 1. I could have said first query is 0 to 7, second query is 0 to 7, third is 0 to 7. If I give you those, in worst case, you will be traversing entire array for one query. Right? And if total queries are Q, then time complexity becomes Q into M. So we speed this up using some clever observation, and we bring in the concept of prefix sum also. Let's see what that suggests. So we will take a look at it once again. First of all, if your query is 1, 2, 3, add 1, I am going to say at index 1, at starting index 1, I am going to add 1 only at that index. Now this 1 that I'm adding here at index 1, I am kind of assuming this 1 will be percolated, this 1 will be distributed, this 1 will be added to every index after that. This plus 1 is going to apply to every index after that. But we wanted this effect to last at 3. So what I will do, 1 to 3, it is okay to have, but at 4, I am going to put -1. So you notice what I did. I have said AL value is equal to +1. I have made +1 at this value. And I am saying A of R plus 1 minus is equal to 1. And this 1 is nothing but this update value. Are we clear with this thing that I have told you, that what we are doing to apply one query? We are not going and touching every index. We are just going to index L to add the value, index R to subtract the value. Are we clear with this part? Yes or no? Okay. Now, what is the benefit of this is, if I go and take a prefix sum array of this array, what will it be? If I take a prefix sum array up to 0, the sum is 0. Up to 1, this value will be 1, the sum will remain 1. Up to this, the sum will again become 1. Up to this, the sum will again become 1. Up to this, the sum will become previous 1 and -1. It will become 0. And that 0 will be continuing going forward. So after doing this change, if I have to do prefix sum, that will just give me the array after the first operation. I will get this if I do a prefix sum of this array now, where this has a value +1 and this has a value -1. This is what the crux of our discussion is, that if I take prefix sum array of this array, I'm going to get my desired output, and that too by doing just 2 updates. Let's continue this process. Now the next query is suggesting 2 to 5, we have to add value 3. So what should I do? What change should be done for the second query? You guys tell me. 2, 5, 3. What is the change we have to do in this array? At index 2, the value is 0. At that 0 value, what should we do? We should add 3. And next end index is 5. So I should subtract 3 from which index? I should subtract from 5 or subtract from 6? Yeah, at 6 index, we have to go and make it -3. Okay, this is second update done. How much time will this update take? Going and updating AL and AR. How much time will this take? Just we go for one time. Yes. Third one is index 3 to index 6. We have to do 2. So 2 should be added to index 3. And 2 should be subtracted from index 7. This is what the next update is. Okay. Now last query is at index 5 add 1. And at index 7. Now if this is 7, we are going to 8 index, but 8 index is not in this array. So what should we do in this case? Do we need -1 to be added, or we can skip it simply? Yeah, we can totally skip it because that does not need to be percolated. Now, after all these queries, our array became this. Now help me get the prefix sum of this array. Up to 0th index, what is the sum? Up to 0th index, what is the prefix sum? It is 0. Up to 1 index, what is the prefix sum? 1. Up to 2 index, what is the prefix sum now? It is 4. Up to 3, it becomes 6. Up to 4, it will become 5. Up to this, it will become 6 again. Up to this, 6 minus 3 will give you 3. Up to this, it will become 1. So we got 0, 1, 4, 6, 5, 6, 3, 1. 0, 1, 4, 6, 5, 6, 3, 1. So ultimately what we are essentially talking about, yes, prefix sum is sum of the previous prefix plus current value in the array. So we are saying for each query, just update 2 indices. So all queries will require q into 1 time, plus in the end you are doing a prefix sum calculation. Prefix sum will take, this is time taken by prefix sum calculation, and this is time taken by update query. So finally the time complexity of this new approach becomes q plus n, and the previous approach we were having, our time complexity was q into n. Now you can better judge q into n will get accepted or q plus n will get accepted. Imagine if array size is 10 to the power 5 range and queries are also 10 to the power 5 range, then we know the first solution will not work, second solution will work better. Okay. So now let's take this background and go back to our question and try to see that what this question is asking us to do. This question says that you are given a string in lowercase and there are some operations start and a direction. Based on the direction, you have to add or subtract something to the current index. Okay, so it is saying index 0 to index 1, direction is 0. When the direction is 0, we have to shift every character backward. Okay, that means A has to be made. A has to be made. Going backward means A will become Z. Okay. If I just ask you to take A back to the previous character, imagine if it is not A. If it is B, what is the previous of B? Back character of B will be A. Same way, back character of C will be B. Only thing is for back character of Z, we have to be cautious. We have to make it like back character of A, we have to make it like Z. So this is where the catch is. We will come back to that later. For now, let's just try to see. I don't want A or Z. I just want the previous value and treat A as its ASCII value. Let's say A is 97. It is perfectly okay if you give me 96 for that. Although we know 96 is not the ASCII value of Z, but I'm saying for now, let's simplify the problem. Let's try to go and get the previous character, which is just current character minus 1. If it is backward, you will do -1. If it is forward, you will do +1. For now, let's stick to this strategy and this approach. Okay. So if we want to stick to this strategy and approach, let's try to apply these ideas. You have A, B, and C. Let's process our queries. First query says 0 to 1, do backward operation. So what plus or minus you will do and where? This is index 0. This is index 1. This is index 2. Tell me what is the operation you are applying to every place. We are adding or subtracting the value. Yeah, guys, this is going backward. So going back means going back from A means we have to subtract or we have to add. We have to subtract. So for now, can I simply say we have to do -1 here? Okay. And what about the reverse of this operation? Query is 0 to 1, do 0. So that means, can I say at 2, I have to perform +1? Is that fair? Are we in agreement with this point? Yes. Okay, let's go and apply the next query. Next query says 1 to 1, 1 to 2, direction is right. That means you have to add 1. So at index 1, you will be adding 1. And now the next index is 2. 2 is outside this string in this is range. So we will not do anything for reversing this operation. Okay. Next is 0 to 2, add 1. So index 0, we will go and add 1. So you already had -1. If you add 1, it becomes 0. and 2 is outside, so just don't do anything. So our array became this. Effectively, give me the prefix sum of this. Prefix sum of this will tell us. Yeah, guys, prefix sum of this will tell us you have 0, 1, 1. What is the prefix sum? It is 0, 1, and 2. Okay. So we got prefix array easily. Right now, we did not worry about A will become which character, but we just got integral value. In A, if you add 0, what character will you get? A only. In B, if you add 1, what character will you get? C. In C, if you add 2, what character will you get? Yeah, you will get E. And that is what the answer is. Okay. So this approach will give us what to add and what to subtract. Now, only thing left out for us to figure out is how to make sure A is getting converted to Z when we are going backward and Z is getting converted to A when we are moving forward. That is where we will apply little modular arithmetic. So let's say I want next character of any character C. Okay, I want next character of any character C. Will it be fair if I say it is C plus 1 mod 26? Just try to understand what I'm saying. Let's say your A is 97. If you do 97 plus 1 mod 26, what will you get? 97 plus 1 mod 26. Sorry, 97 should be converted to 0, my bad. So 97 should be converted to 0. I subtract from it A so that I get the ASCII value, add 1 to it and do mod 26. Will that give me the next character? Or what has to be added to the next character? Will that give me? Okay, or let me reword this, whatever I said. Let's say you have indices 0 to 26. 0, 1, 2, 3, 4, 5, all up to you have 25. Okay, these are the indices. You want next index of any index. What I'm saying is the next of 0 to the right of it is what? What is the next index to the right of 0? 1. Will it be fair if I say idx plus 1 will give me the next index? For 0, it will give me 1. For 1, it will give me 2. For 2, it will give me 3. 3, it will give me 4. But for 25, if I say next index is going to be 0, if I do 25 plus 1, will that give me 0? No. But if I do 25 plus 1 modulo 26, will it give me 0? Yes. So this doing plus 1 and mod 26 is a way. After 21, we can get back to 0 once again. So this is to get the next index. Same way, if you want to get the previous index of any index, can I say index minus 1 will give me previous index? Previous of 25 is 24. Previous of 24 is 23. Previous of 5 is 4. Previous of 4 is 3, 2, 1. This formula will not work for one index. Which index this formula will fail for? If we take 0 to 25 to be a circular indices, it will fail for 0. A trick for that is, if I add 26 and do mod 26, just tell me, will this formula work for 0 now? Will this formula work for 0 now? Yes. Now you may ask, why did I add 26? Because if this is 0, this will make this value as negative value. And one proven fact about modulo is, if I ask you what is 2 modulo 5, tell me guys, what is the value of 2 modulo 5? It is 2. If I ask you what is the value of 2 plus 5 modulo 5, what is the value of 2 plus 5 modulo 5? That is also 2. Okay, again, if I ask you what is 2 plus 5 into 2 modulo 5, what is the answer for this? 5 into 2 is 10, 10 plus 2 is 12, 12 modulo 5 will again be 12. So that means modular arithmetic tells us if you are trying to do a modulo m, it is going to be same as a plus m modulo m. It is going to be same as a plus 2m modulo m. That means adding m does not change the answer, but adding m here helps us convert the negative value to positive value. That's the whole reason we added this. Okay, so this idea helps us get the previous index in a circular order. If we combine these two concepts together, then you feel this problem is easily solvable. Yes. So you have to apply the concept of modular arithmetic plus the range update, where we are not updating every range immediately because that may become a costly operation. And that's the whole idea. I mean, just to show you the skeleton, for every query, I took a kind of an array, which is integer array, filled them with zeros. For every this, I'm checking based on direction. If direction is 0, sign is -1. If direction is 1, the sign is +1. And what I'm doing is I'm going to that particular index and I'm adding 1 into sign. And if r plus 1, if the right side index is part of the string, I'm subtracting that. So it was like add to L and subtract from r plus 1 index. And after doing these operations to every range, what we have to do, once every shift is taken care, once every query is done, after this, what was our next step? I have a V array where the effect is captured of every operation. After that, absolutely, we calculate the prefix sum. So for this V array, we have to calculate the prefix sum. So if you see, I'm just calculating prefix sum. And the moment I'm calculating prefix sum, at the same time, I'm also doing modulo 26. Why? If in A, I'm adding 26, then eventually it will roll back to 0. So this is one additional thing that we are doing. And now we are saying if prefix sum is less than 0, I'm adding 26 before doing modulo. I'm converting A to 0, B to 1. So this is like converting to index, and then it's like character to integer and integer to character conversion. So this mapping is just making sure that where it will get translated. Yeah, so for negative value doing this, positive value doing this, that's it. Ideally, I did not need if else. I could have just gone ahead and added plus 26 to positive also. Doesn't matter prefix sum is positive or negative. I can continue to add 26 in both the cases and I would have got the answer. So this if else is unnecessary. Only this line was sufficient for both cases. And finally, we are returning what is the answer. And answer is where I'm appending the characters. That's it. So this was about range updates. So I hope this was a useful discussion. Any questions, any doubts, any other ideas people use to solve this problem? Okay, so yeah, Shashank is giving one more thing. He's saying rather than adding 26, he's adding a very high value, which is actually a multiple of 26. So he's saying you will not need this. So he's multiplying it with a very large value. Yeah, that would also do. Yep, Shashank. So that is also fair. We are again using modular arithmetic in a different way. Okay, so that is this question.